so far we've covered, I mean, this last week, part of last week, and most of all this week, we've covered multiplication and division. That's the only thing we've really done so far, yes? Well, today and tomorrow, we're going to be covering addition and subtraction. Now, addition and subtraction, why is it going to take 2 days? Because when we look at this here, I know I can add two fractions if what?
They have the same denominator.
The denominator. If the denominators are the same, the bottom of the fraction is the same, I can add the numerators. Now, the denominator does not change because it's going to stay the same. And we add the numerator, so 7 plus 3 is?
5/2x.
Because 10/4x do have a common factor, and if there is a common factor, we need to reduce it. 10/4 is the same as 5/2. They have a common factor of 2, so we can reduce it. And that is it. Now, we wouldn't put any restrictions for this here, because the only restriction is when x is, but it's still listed, so we don't have to list the restrictions for this here. Okay, let's look at the next one. Well, the denominators are the same, so we would subtract the numerators. Now, we do need to make sure there's no common factors on top and bottom. So when we look at 2x minus 5, well, there's no common factors between them. There's no way to factor it. And there's nothing in common on top and bottom, so we are done. Questions on this here? Oh, wrong direction. Okay, so we have 8/12x minus 5/12x. What can we do first? We can just subtract. Right, because since the denominators are the same, we can subtract, so we can do 8 minus 5, which would give us 3. 3/12 gives us 1/4x. Why would I not simplify the 8/12x?
Well, because you gotta subtract it first.
Right, because what would happen to the 12x? It would become what? 6x. The denominators would not be the same. Because then we'd have to make them be the same by making it back to 12. Well, it'd just be a waste of a step. How about the next one? 1/x squared, because we can, the denominator is the same, so we can add them. We get 3/3x squared. 3/3 reduces, and we have 1/x squared. And that's it. Questions on this here? Let's skip number 3. Let's look at number 4. So I know that the denominators are the same, so I can add the numerator. So we get 2x squared plus 2 over x squared plus 1. So we just added the numerators because the denominators are the same. Is there anything we can do after that?
Could we make it 4x squared? Or
no.
Just 2/1? I'm not doing this to 2/1.
Well, there's a common factor of 2 on top, yes? So I can factor it out, and what would I be left with? X squared plus 1, and on the bottom I have x squared plus 1. So we can factor something out of the numerator. Move that up a little bit. Well, wait a minute. Do we have something in common on top and bottom? X squared plus 1, so those will simplify out, leaving me with 2. But this time x squared plus 1 did simplify out, yes? So we might have some restrictions. So what value of x is going to make x squared plus 1 equal 0? That might be a little bit hard to see, yes? So let's go on and solve it. So we would subtract 1 from both sides, because those would cancel, leaving me with x squared is equal to -1. And then we would do what? Square root both sides is equal to plus or minus I. So is there a value of x that would make this 0? Well, no, not a real value, because we have I. So that means we don't have any restrictions because there's no real values of x that will make this equal 0. So the answer is 2. That's it. Questions on this here? So we like addition and subtraction, yes? At least for now. Unlike denominators. Because it's not always going to work out that the denominators are going to be the same. So we need to make the denominators be the same. Now, the way that we make the denominators be the same is using something called LCM. Least common multiple. And greatest common denominator and least common multiple are probably two of the most flipped things. Get them backwards. Because greatest common denominator, we're looking for the smallest or kind of the biggest number that will go into all of them. Right? So you're looking, when you get all the factors, you're looking for the smallest number that will go into everything. Least common multiple, we're looking for the biggest number that I can make everything be. And I always, because I remember this even in middle school or whenever I went over this first time, like, this seems backwards. We're doing least, but we're finding the biggest. What? So for this here, unlike with numbers, because it was tricky with numbers because you had to factor everything out using the prime factorization, I think having parentheses when we factor these down are easier to work with and get to. So we're going to do 2 of these here to work with this here, and then, actually, we're going to do 1, and then we'll move on, because I think I'm going to pull some of these out, because I feel like y'all can get this, and we can go over this easier when we're actually adding and subtracting fractions. Now, when we look at this here, 4x squared minus 16, and 6x squared minus 24x plus 24. We have these two here. We want to find the least common multiple. Well, to get that, we're not going to just jump straight into finding the least common multiple. We want to factor both of these here. So when I look at 4x squared minus 16, how can we factor this? We can take out a 4. Because if I factor a 4 out of 4x squared, I'm left with x squared. If I factor a 4 out of 16, I'm left with 4. Yes? And essentially, we're dividing each term by the greatest common factor. That's what's left inside the parentheses. Now, x squared minus 4 will factor to what? It is. It would be a difference of perfect squares because x squared and 4 are both perfect squares still, even with pulling the 4 out. Now, in some cases, even without pulling out the 4, 4x squared minus 16 is still a difference of perfect squares. But for what we're going to do, we want to pull the 4 out. We want it out. Because it's going to change what the least common multiple would be if we left it in. Well, it wouldn't change it. We would get the wrong one. And that's as simplified as it gets. Now, if we look at the other one, this one here has a greatest common factor of what? 6. So we can factor it out. And if we factor 6 out of 6x squared, we're left with x squared. If I factor 6 out of 24, if I pull 6 out of 24, we're left with what? 4x plus 4. We're left with 6x squared, or x squared minus 4x plus 4. Now we can factor this down. Now since the 4 is positive, the signs are the same and they match the sign of the middle term, which would be both negative. Factors of x squared give us x and x. So what factors of 4 would we use? 2 and 2. Mm-hmm. Grab a different color. So we have both of them factored as far as they will go. So we need to find the least common multiple. Now for the parentheses, we'll do them here in a minute. We want to look at the numbers, 4 and 6. What is the smallest number that I can make 4 and 6 be the same? So 2 is the greatest common factor between them. We're going up. So what number can I multiply 4 by? Or what number 4 by to, let's see here. There's a number I'm looking for that when we multiply by 4 and 6, that'll be the same. No, that's even more confusing. 12. 12 is what we're looking for. 12. It's 12. We're looking for the first number that 4 and 6 will be the same as. Now, there are other numbers after it that'll work because 12, when I looked at it first, wasn't the first number I thought of. The first number I thought of was 24, yes? But what's the difference between 12 and 24? Well, 2, right? And when we start solving these and adding and subtracting them together, any additional factors I add to the least common multiple, I will have to pull out later, which 2 is not a big deal. The issue comes in when we start adding one of these sets of parentheses, because if it works out what I was needing to factor at the end was a quadratic, a degree 2, but I added an extra set of parentheses, it's not going to be a quadratic anymore, it's going to be a cubic. If I add 2 of them, it's not going to be a cubic anymore, it's going to be a quartic, it's going to be a degree 4. Each one of these we add makes the numerator, what we deal with at the end, bigger. Does that make sense? So making sure we have the least common multiple is going to make these problems easier on us so we're not adding extra factors back in. So 4 and 6 is going to be 12. Now, as I said a minute ago, the parentheses are what I think is the easier part of this here. Now, what I do when I look at this here for least common multiples with parentheses is, well, okay, I'm going to take both of these. I grab both of them for one of the two expressions or multiple expressions. I just grab all of them. So for the ones in blue, I grabbed both of them, the x minus 2 and the x plus 2. Okay? What does the one in green have that I don't have listed here? So this here, so I have an x minus 2, don't I? But it also has a second one, doesn't it? So, done. Because again, what we're trying to do is make it so that I can make both of them be the same. So that means if I'm trying to make them be the same, well, the least common multiple is going to have at least both of these here. Well, wait a minute, this one had one more. Add it, we're done. That's it. So when we add or subtract, the common denominator, or what we're going to make the denominators be the same as, would be this here. We're trying to make them be the same. And that's what this least common multiple is. That's what the goal for doing this is. Okay? All right. I know I have multiples of these here. Let's go on and look at one, because I feel like when we start looking at this here, trying to make them be the same, least common multiple adds it's helpful, but not always. Okay. Back up. All right. We're going to find the sum. Now, as we can tell already, and we can look at this here, the denominators are not the same, correct? 9x squared and 3x squared plus 3x are not the same. Okay. Well, we can't factor x and we can't factor 7. 9x squared, I think that's as simplified as it gets. Yes, it's a term. We can't do anything with it. But can we factor the 3x squared plus 3x? Well, yes, it has a greatest common factor of an x. So what does that leave us with inside the parentheses? Okay. Now this here, what we're about to do is probably going to make least common multiple seem not as necessary anymore. Now what we're wanting to do is we want the denominators to be the same, yes? Okay. That means I'm going to have to multiply each of these denominators by something so that they can be the same, yes? Okay, we'll start on the one on the left, the 9x squared. So this is what we have, yes? Well, we need the one on the right, this one here, 9x squared to be the same, yes? Well, I have 3x. Well, what do I need to do to 3x to make it be the same as 9x squared? Right, because 3x times 3x would give me 9x squared, yes? So that's the same. So now, with this multiplication, does this rational expression, this fraction, have everything that this one has? Well, yeah, with that 3x, they would be the same, wouldn't they? Because this fraction now has everything that this one does, yes? Okay, now we're going to go the other direction. What does this fraction have that this one doesn't? On bottom, we're looking purely at the x plus 1, yes? Okay, I'll multiply it by x plus 1. Because that's really what we're looking at, least common multiple. We're wanting them to be the same, yes? So we could go through and factor it and look and see how do I make them be the same, or, well, the one on the left is missing an x plus 1. Let's multiply it by it. The one on the right's missing, oh, we need 3x for it to be the same as 9x squared. We'll multiply it by it. Is that a little bit easier than least common multiple? I mean, with parentheses, it does. With numbers, if we're purely looking at two numbers, least common multiple is a little bit more helpful. But I can't multiply just the denominator. I also have to multiply the numerator by it. Really, what are we multiplying both of these fractions by? What's x plus 1 divided by x plus 1? 1. We're just multiplying both of these fractions by a fancy version of 1, yes? That's why we can do this. Okay, any questions on this here so far? So this is kind of making sense a little bit, liking this a little bit better than just doing least common multiple. Because if we're looking at this from a pure mathematical standpoint, we would have figured out the least common multiple onto the side, and then seen, okay, what do I need to do to 9x squared to get to that least common multiple? What do I need to do to 3x times x plus 1 to get to that least common multiple? I like this way better. Now, the denominators, we're not going to multiply out, because it's just going to be 9x squared times x plus 1. 3x times 3x will give us 9x squared times x plus 1. And when I say multiply out, I'm not multiplying through, we're not distributing through that x plus 1. If we have multiple sets of parentheses, we're not going to multiply them out. Because if you notice on the first ones we did, we ended up with how many fractions at the end? Well, 1, right? And if anything's going to cancel out on top and bottom like we did with multiplication, I have to have the denominator factored for that to work, because then we can cancel out. So we don't ever multiply through the denominators. Well, the numerators are going to end up being what? Added or subtracted, yes? Okay, we've actually got to multiply the top. So that means I have to multiply x plus 1 by 7. We have to do 7 times x, which would be 7x. We have to do 7 times 1, which would be plus 7. We actually have to do this. We have to multiply through. Now on the other side, we're going to have 3x times x, which would be Now the denominator is the same. Yes, so that means we can add the numerators. And according to number theory, 3x squared would go first. Plus 7x plus 7 over 9x squared times x plus 1. I'll tell you right now, this is as simplified as it gets because 3x squared plus 7x plus 7 is not going to simplify further than that. That's as simplified as it gets. So we could have, especially on the homework, if you want to check, the b squared minus 4ac is the easiest way to kind of see, is it factorable? Because if the number that comes out of this is a whole number, no fractions, or well, you won't get fractions. As long as it's a whole number, it's good, because if it comes out imaginary, it doesn't work. If it comes out as an irrational number, a non-repeating, non-terminating decimal, it doesn't work. Questions on this here? No, I'm just going to mark. Next page. You can do it. There we go. And this here is why this is why it's going to take 2 days, because we're going to go through more examples of this again tomorrow. Because doing these here is sometimes hard to see. Okay. So I can't factor 8 or, let's see here. What can we do first? Right, there's a common factor of 4 and 8 and 12, yes? So we can factor that out, because if I factor 4 out of 8, I'm left with 2. If I factor 4 out of 12, I'm left with, and I have x squared. We can't do anything with x on top, but in the denominator, what can we do? I can factor out an x, yes? Which leaves me with x plus 1. What can we do next? Yes.
Why didn't we write a 4 out to the side of the 2 and 3, but we did put the x?
And the last one?
No, this was not good. We took 4 out of 8 and 4 out of 12.
Mm-hmm.
We didn't put a 4 beside it, but we did put an x.
Yeah, because since here it's on top and bottom, these would reduce to 1.
Okay.
Now, on the other one, the other set of fractions, here I got this from the denominator. I pulled an x out of the denominator.
Okay.
Now, it just works out there as an x on top and bottom, yes? So can we reduce that? Will it be helpful? Here, I'll go on and erase this here, because I think you all have it written out, yes? So let's see what happens. So I have this here, yes? Okay, the denominators are obviously not the same, yes? So over here, I'm going to have to multiply on both sides. I'm going to have to multiply it by something. Well, here I just have x plus 1, yes? So what does this fraction's denominator have that this one doesn't? 3x squared. Okay. So we multiplied on top and bottom, yes? Simplified it out. Now say I didn't. Say I didn't simplify it. We have x and x. Well, I don't need 3x squared anymore. What do I need? It already has 1x, so I just multiply it by and 3x. So here, did it make a big difference? Well, no. So it sometimes is helpful, sometimes is not. Because simplifying it, it didn't change anything. Because even without it, it just means that this is squared. So there's nothing wrong with that. It would almost be the same thing here as if this was a 2. Or not a 2. Let me rewrite that. Let's say 4. 4 is going to make more sense. Well, if I have a 4 here, oh, wait a minute. I've got to multiply this by 4 over 4. 4 times 3 is 12. Y'all see that there? So sometimes reducing on top and bottom helps. Sometimes we end up back where we were. So don't be hesitant to reduce something on top and bottom just because we might have to put it back. It can sometimes help. It can sometimes make these a little bit easier to work with. Okay, any other questions on this here? Now, what is the other fraction, that one on the right, missing? X plus 1. Now again, on the denominators, we aren't going to multiply through, so we're just going to have 3x squared times x plus 1. And over here, we're going to have 3x squared times x plus 1. Now here in the numerator, we're going to have to distribute the 2. So 2 times x would give us 2x. 2 times 1 would be plus 2. 3x squared times 1 will be, well, 3x squared. Any questions on how we got to this here? Okay. We can add these two together and rewrite it according to number theory. And this here is our final answer. Because 3x squared plus 2x plus 2, that's not going to simplify. There's no way to factor it. So this here is as simplified as it gets. Questions on this here? All right. Find the difference. We're going to find the difference of these two here. Now the numerator x plus 2 is not going to change. The numerator negative 2x minus 1, that's not going to change. Those are going to be the same. Because there's nothing we can factor out, there's nothing we can simplify, and even if we could, we leave them alone. Because again, if we're adding or subtracting, well, if things are factored in sets of parentheses, the only way I can add them to something else or subtract them from something else is to multiply them back out. So we don't normally factor the numerators until the very end. Now the denominators, because they're different, 2x minus 2, we can do what? We can factor out a 2, which would leave us with an x minus 1. Because the 3 is positive, the signs are the same, and they match the sign in the middle term, so they're both going to be negative. Factors of x squared would be x and x, and the only factors of 3 are what? 3 and 1, 1 and 3. Okay. Okay. So what does this denominator have that this one doesn't? And that's it. Because it has, the only other thing that the one on the left has, this denominator has, is x minus 1. It already has it, so we don't need it. The only thing it has that this one doesn't is the 2. Now if we go the other direction, this one here has x minus 1 and x minus 3, so this one here is missing an x minus 3. So I need to multiply top and bottom by x minus 3. Questions on this here? Well, if we look at this here, x minus 3 times x plus 2, that is going to give us a quadratic. Yes? This here, because if we added x minus 1 in there again, multiplied both of them by x minus 1, Well, wait a minute. X minus 3, x plus 2, and x minus 1, that's not a quadratic anymore. That's a cubic. That's going to make it harder to work with. And that extra x minus 1, any of these extra sets of parentheses are going to come out in the end. So we have to factor them back out because they weren't needed. Okay. So the denominator is going to be 2x times x minus 1 times x minus 3. Now, the way that you order these is not going to matter. The main key thing I would say is put 2x in front. Don't put 2x between the two sets of parentheses. That's just not something you do. Okay? It's like having a basketball jersey numbered 99. It doesn't work. Either that or that's a really weird ref. Okay, now what we need to do is we need to multiply the numerators out. So for the first one over here, we can go on distribute. X times x is x squared. X times positive 2 is going to be plus 2x. Negative 3 times x would be negative 3x. And negative 3 times positive 2 would be negative 6. Now over here, we're going to multiply both of these by 2, which is a little bit easier. Negative 2x times 2 would be negative 4x. And negative 1 times 2 would be negative 2. Any questions on any of this here so far? Okay. Now we can combine some like terms to make this a little bit easier to work with. 2x minus 3x would be negative x minus 6. Okay. So we have everything simplified. Now we can go on and subtract. Yes? Y'all need to be careful with this here, especially with subtraction. You need to be careful with the signs. Because it is going to be on one fraction, and the denominator will be 2x times x minus 1 times x minus 3. There's nothing wrong with that there. The x squared minus x minus 6 is fine. We'll go on and put them in parentheses. Minus. The second one that we're subtracting, you need to make sure you pay close attention to the signs, because it's going to make a difference. Because we're subtracting both of these here. Essentially, we end up multiplying both of them by negative 1. Which for addition didn't do anything. Addition doesn't change the signs. X squared minus x minus 6, there's nothing going to change here. But we have to apply this negative to both the negative 4x and negative 2. Well, negative 4x, if we subtract a negative 4x, the negative and negative would make a positive. So that really this is plus 4x. The negative and negative 2 is going to make it plus 2. So if we're not paying close attention, it is very easy to get one of these signs wrong. It is very easy to get one of these signs wrong when we're doing subtraction. Questions on this here? Okay. Now we can go on and actually subtract and combine like terms. And when we do that here, well, x squared is by itself. Negative x plus 4x is going to be plus 3x. Negative 6 plus 2 would be negative 4. Any questions on how we got to this here? Any questions on any of this here so far? Well, it works out that the numerator will factor. X squared plus 3x minus 4 will factor. This here will factor. Well, since the 4 is negative, the signs are opposite. And what are the factors of x squared? And x. Now the factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? Which one do you think it is? 1 and 4. Which one's going to be positive? Which one's negative? And one's going to be negative. And it does work out because we'll have x times negative 1 would be negative x. And 4 times x would be plus 4x, which gives us a positive 3x, which we wanted. But it does something more than that. What does it do? Top and bottom have what? Common factor of x minus 1. So it will simplify, it will reduce, which leaves us with x plus 4 on top and 2x times x minus 3 on bottom. And for the first time today, we will have a restriction. And what's our restriction going to be? A 1. Because we lost this here, this x minus 1. And when you set it equal to 0 and solve, we'll add 1 to both sides and see that it's 1. So x cannot be 1. And this is where we're going to stop here for today. We'll pick this up tomorrow.